Hello, everybody. My name is Maxim Orlovsky, and today I would like to talk about the RGB protocol, which is going into the production release this summer during these days. And I would like to explain, to give a brief introduction, what the protocol actually is and why it is important for the Bitcoin and Lightning world, as well as describe the recent advancements we brought to the protocol over the last year and explain how people can start using RGB after waiting for its release for quite a few years. So let's start with what RGB is. RGB is the first client-side validated technology, and client-side validation actually is about reviving the peer-to-peer nature of the original ideas coming from Satoshi and before him, such that finally we can reduce the role of centralized players or intermediaries, including miners, and finally get people transacting directly peer-to-peer without the need to send all the transaction details to the miner, without the need to download them from the miner, and being able to just send funds without any additional party between them. It is not just a peer-to-peer transactions, it is smart contracts. So we are talking about universal programmability, something that frequently called Turing completeness. And this programmability is being unlocked for Bitcoin without any soft forks required. And that's also where the power of client-side validation shines. It is also a very private technology. Its privacy comes from two main things. First, because it is peer-to-peer, you don't have a global ledger. There is no informational centralization anymore, because in fact, blockchains, while they are computationally decentralized, you have a network, it is still informationally centralized thing. Everything is kept in a single ledger. Yes, all the members of peer-to-peer network download all of this ledger, but all the information resides in this single place, in this distributed ledger. And that's why anybody, any party accessing this ledger can actually track the whole history of the transaction graph and do chain analysis and many other things, which ultimately breaks privacy. And before the client-side validation, every innovation coming to bring privacy into blockchain had to face the same restriction. There is still a global ledger. Even with Monero, even with the ZK, there is still a transaction graph. What you hide is the details of the transactions. Maybe you can cut through some of the parts of the transaction graph with like Mimblewimble or something of that sort, but still you have a single centralized ledger. And the client-side validation is the first technology that brings these to end, because you don't have a global ledger anymore. When you send a transaction from a peer-to-peer, nobody else in the world knows about that. You don't publish this information into any ledger, global or partial, and that's where the privacy actually sticks in, because it's a bearer rights smart contracts. It's like with a paper world where two parties doing a contract had just two copies of this contract kept at their homes at the safe. There were no centralized registry where they need to bring that to. And that's actually the real decentralized privacy and the power of decentralized technologies which will shine. And the second thing is that client-side validation also comes with a ZK compression. And this ZK compression allows you to hide even this private part of the history, such that even though you have the history of your assets from the original issuance of these assets or genesis of them, you can compress that such that the details, the overall history graph of on your client-side part is also hidden. And you just can prove that you indeed received these assets without any double spending during the whole route, but you can't explore into the details of the transaction graph. And because of this combination of factors, like compression, peer-to-peer nature, absence of centralized ledger, finally, the main scaling problem of blockchain is solved because you get rid of blockchain. And that's probably the only proper way of solving the blockchain scalability issue. And at the same time, this technology leverages the existing decentralized technologies like Lightning, and it's also, for instance, ARC compatible. It is compatible with anything that can be built with the Bitcoin transactions, and it runs without putting any information into Bitcoin blockchain, information which can be detected or parsed by an independent party not knowing about the contracts. So that's why RGB is a huge thing, and that's also why RGB took so long to develop. And unlike the blockchain, where you have a distributed database, because any blockchain is a distributed database with a number of nodes synchronizing the history log of the transactions. And in blockchain, all the users has to agree upon this history of transactions. So basically, everybody needs to download and verify everything for everybody else, and everything that happened in the world. That is intrinsically not scalable. And for n peers, you need the same amount of effort as the n to check, verify, and store. With the client-side validation, this constraint is already removed. They keep only their part of the state. And for n peers, you need much less storage requirement, like a logarithm of the number of peers, and even smaller validation requirements, like a second power of the logarithm. And yes, this all operates on top of Bitcoin, as I already said, and also on top of technologies which can run on Bitcoin, including but not limiting Lightning, pay joins, coin joins, ARC, or whatever will be multi-sigs, mu-sigs, Schnorr signatures, or whatever will be invented and brought to Bitcoin in the future. It also extends the capabilities of Bitcoin itself without any software, bringing programmability, much better privacy, more assets and finance into Bitcoin blockchain without putting any data and not occupying any space on Bitcoin blockchain. And yes, as I was starting to saying a few slides before, that's why it took quite a long story to build that technology. This technology stands quite apart from the way you usually build a blockchain-based application. And in many ways, it's a new world in the computer science of distributed systems. So we passed through many iterations. We have started in 2016. In 2019, I joined the project, and we got through iterations which tried to bring much more powerful and computational power into RGB and client-side validation. And finally, here we are here today. On the very high level, I can say that we've gone from the idea of just building a better colored coins on top of Bitcoin to the idea of full-fledged smart contracts, Taproot compatible, operating on top of Lightning with a full support for ZK, Starks, compression, and privacy-related technologies. Over these years, there was a lot of companies and individual contributors who was working on RGB, bringing ideas and contributing ideas to RGB. It was more than 100 individual persons and more than 20 companies from pretty much all the world. And that, like summarizing this, I can say that it was a real global community effort. And the only things which can compare to that, it was probably the Bitcoin itself and Lightning Network. And these days we see that in ARC to a certain extent, but basically these are the only examples of technologies built in such a way. Nothing in the crypto, like other blockchains, forked Bitcoin versions, or any decentralized blockchains which were created can't compare to this scale of effort. So what we are going live with is RGB codename 0.12 version. So it's a 12th iteration through all these 6 years of development. And we believe this is a final iteration because in this iteration we have all the functionality we were striving from the initial version, including the full programmability, necessary level of privacy, and finally, only with the 12th version, we have got ZK Stark compatibility and ability to compress the history and hide the history on the client side as well. And this 0.12 version, which will go into the production with the mainnet assets in just few weeks, is also brings a lot of improvements in terms of performance. It also simplifies many things which have grown up through all these years of development and were hard to understand by developers and people integrating RGB. Now they are much more compactified and simplified and made in a more straightforward way. And as I already said, probably the most interesting and intriguing part of the 0.12 version is its ZK Stark compatibility and readiness. So we've got quite a lot of things in this version, so I will briefly cover the main advantages which happens. First of all, I would like to say that in this version, for the first time, we have achieved much simplification without sacrificing any of functionality. Because you know that when you develop for many years a technology, a code base is growing up, you can add more and more features. And this time we did a complete revision such that many redundant features were removed and many things which can be done in more optimal way were simplified because we received a feedback from people who were trying to use RGB and integrate RGB into their products. So there was a number of things we made much better at the consensus level. For instance, we got rid of some specifics of dichotomy between different types of seals based on taproot or more legacy-based schema of op return, which is needed for hardware wallets and Lightning Network. We got rid of some old ZK encoding schemes because now we have ZK Starks. We don't need Pedersen commitments or bulletproofs, which is really hard to bring into production. There is much less need to write a complex schema for issuing an asset. You just do it in a very simple way. And there is no such thing as an ordering of operation, which actually had a very risky ambiguity because you have now two transaction graphs, Bitcoin transaction graphs and RGB transaction graph. So this part is removed and you don't need to try to reorder RGB operations according to the on-chain operation history. We also simplified a standard library which should help integration of RGB into wallets and exchanges. And basically all this simplification resulted in this thing. So if you look into the number of code lines reported by a service called code coverage, which counts the test coverage of the source code, it also computes the number of lines of the source code. And you will see that basing on this data, there was nearly 4 times less number of line codes in the new 0.12 version of RGB. So this can be compared to something of this evolution of Falcon engines of Raptor engines from the SpaceX rockets. You see that with the time you can finally get the simplicity, which is really important and required for things such as auditability, reduction of attack surface, or simplicity of the integration, and also the code maintenance over the years. So 4-time reduction of the code base is really significant thing. Pretty much the same effort was put into the standard library. And here, well, the standard library is not that critical as a consensus layer. I will explain what's the difference, because if something goes wrong in the consensus layer, all the assets, all the contracts issued so far will be broken. And if you try to fix it, basically every asset issuer needs to reissue the asset. There should be a migration procedure. So it's a really big thing. On the other hand, standard library makes it easier to use RGB from the software integration perspective. But if something wrong with that, if there is a bug in the standard library, the only thing you need to do is to upgrade your wallets. All the existing assets, all the existing contracts are safe and nothing has to be changed there. So it's a big difference between these two layers. And in standard library, we were able to also reduce the number of code lines nearly twofold, which is also significant achievement. And if you think about, like, it's just 2,700 lines of code for the consensus and 3,200 lines of code for the standard library. It's a very, very tiny and compact thing, even comparing to Bitcoin Core or any other type of that decentralized system. So it's easier to read, understand, and audit it. And one of the things we will do after the release, we will do even a book, like was done days ago for PGP, when we will publish all the source code as a small booklet for RGB, such that anybody can read it, audit it, and understand it. Other than complexity reduction for the code base, we did a lot of performance improvements, such that RGB can actually operate in high load environments where you don't need to read all the data into the memory. And the RGB standard library and consensus can be run on hardware devices like wallets, so they can do the verification themselves. Even if the data you send peer-to-peer is multiple megabytes or hundreds of megabytes, if you don't apply ZK compression, it still can be verified on hardware device, because we are now using a streaming. So you send the byte to byte, byte after byte to the hardware devices, and it accumulates the state and does the verification without storing all the data in memory. So there was multiple different improvements in this regard. We also improved the payment workflow such that we can now support all the possible payment scenarios. Before, we had already support for Lightning and ARC pay joins and coin joins, but in 0.12 for the first time we were able to add the payment aggregation with a so-called payment script. So if you're doing 10 payments at once with the different assets under different contracts, you can aggregate them in a single operation, and also you can aggregate them into a single Bitcoin transaction, which either goes to Lightning or on-chain. We also brought payment scenarios which involved a linked consequence payment, so that you can build a whole graph of payments in advance and then sign it at once and publish it at once without waiting for each of the transactions to be confirmed. And finally, we brought support for multi-asset contracts, such that in invoices and other parts of the system, you can have a contract which exposes multiple assets, for instance, two different forms of tokens, or two different forms of NFTs or their combination, which can be quite important for DeFi applications. Then, as I said already, the most probably impressive part is the ZK-Stark compatibility. We call it ZK-Starky RGB, meaning that, like, how the ZK-Stark operates. Basically, the ZK-Stark has a prover which takes certain computation, and it produces a proof out of this computation. And the proof is compact. The computation can be large, pretty much arbitrarily large, but the proof is fixed size compact data. And then everybody can verify this proof in a logarithmic time to the number of operations. So it's a very robust thing. But it basically consists of two aspects. The first thing, that you have to have a system able to present itself in a form that a ZK prover can compactify and prove. And second, you need a ZK prover. So when we say about RGB becoming Starky, it means that now RGB can be presented in the form, the RGB history can be presented in the form that any ZK-Stark prover can take and produce proof with. So RGB itself wouldn't contain ZK prover. We will use existing provers. Probably it will be S2 from Starkware, or maybe over time we will have a better ones. So we don't develop ZK prover itself, but we have RGB which is able to be proved with any ZK-Stark prover in a very efficient form. without the need of producing a lot of things, because, you know, for instance, certain hash functions are not optimized and many computational operations are not optimal for ZK provers. Here we made RGB fully optimized for a ZK prover. And in doing that, we have to significantly rework and actually rewrite RGB architecture. That actually gave us the possibility to dramatically improve the performance and reduce the code base, as I was describing before. And we have to move from normal von Neumann architecture, where you have a RAM, CPU, and input-output devices, because in the smart contracting world, you already don't have many of these concepts. You don't have like the same input-output as you have in normal machine. You don't need the same RAM as a normal machine. And actually, in modern days, we are not using von Neumann. We are using modified Harvard architecture. So we came up with this thing we called Sonic architecture for RGB. And it's basically a polynomial computer. Why it's polynomial? Because ZK Stark prover works with the mathematical polynomials. And you need a computer which can represent itself as a set of equations made with the polynomials. And to do that, first of all, we have to replace the CPU with a ZK-enabled virtual machine. Second, instead of input-output, we have the access to the transaction data, which has to be representable as finite field elements, so that they can be put into a polynomial equations. And we also, instead of random access memory, instead of RAM, we have a capability-based memory consisting of a specific cell. So you don't have just memory which you can randomly address. It's a very cell-based form of memory where each cell is made of polynomial elements, finite field elements, which can be used in polynomials. And the KVM operates with two of them, and the verification program is run on top of the KVM. We call it Sonic because it's abbreviation of this capability based memory. You can Google and find in Wikipedia more information about capability-based access, resources, and memory. It's very interesting growing field of the computer science. I wouldn't go into much details now, but basically we believe that it is the future form. So the most real-time, the best real-time operating systems today, and the new generation of operating system like Redux, written in Rust, they're all using a capability-based resource management. It's the next stage of the evolution of computational platforms, and RGB made with the capabilities kept in mind, where these capabilities actually link the state to the world we used to the blockchain world, to the UTXO-based world, where a mechanism of so-called single-use seal. So you probably, if you looked into RGB over these years, you heard about single-use seal. So basically, single-use seals is the glue which becomes capabilities from the perspective of polynomial computer used in the new RGB version. And this computer, when it computes on the smart contract, which is universal, it runs all these operations. And these operations have input and output, which converts into the arithmetical trace, which can get into the arithmetical representation through arithmetization, and so on, up to the data which are sent to the ZK Stark prover. All these parts are open source, of course, and because we have RGB as a dedicated smart contracting system on Bitcoin and Lightning, we also have a dedicated organization for this underlying polynomial computer used by RGB, and other projects other than RGB can actually also make use of this polynomial computer. You can find it in the GitHub organization called Alluvium. And that's the way how the assembly written for this polynomial computer looks like. It's pretty much the same assembly you wrote for many other architectures. And finally, we put a lot of effort in reducing the attack surface of RGB. Other than just reducing the complexity, we also increased a test coverage. Before that, some parts of RGB code base was really poorly test covered. We brought it up more than two-thirds of the whole code base, and we are happy that the consensus and especially Alluvium is covered for about 90% of the code base. And it makes sure, in this way we can make sure that some attack scenarios, because this unit test includes attacks at the consensus level, different scenarios of attacks. We make sure that the RGB is really production ready. And one of the issues we found with that actually there were a very advanced attack with a Bitcoin block reorganization issue, because in RGB, you break the Bitcoin transaction graph. You still put the commitment data into Bitcoin transactions over the blockchain or the Lightning channel, but you can't force Bitcoin transactions to be ordered the same way as RGB operations. So you can put a commitment on later RGB operation into earlier mined Bitcoin transaction, and then put the commitment to the earlier RGB operation into later mined Bitcoin transaction. On one side, it brings a lot of privacy and it totally and utterly destroys all the chain analysis capabilities. On the other side, you can design an attack where you can mine a deep RGB operation just in the most recent block, then do a rework and revert a large part of RGB history. And in 0.12, we were able to provide a mathematical formal model for such an attack and protection from this attack, and ensure that actually the way we re-implemented the handling of this attack is formally provable to be safe and secure. Unfortunately, it wasn't possible with the previous versions due to certain architectural limitations. So that's all new coming with 0.12, and the main question is when mainnet? The short answer is now. The more detailed answer is yes, we've been with the version 0.12 through a long process. We started development in October 2024, and we passed through integrational tests, unit test coverage, internal audit, and now being in the stage of external audit. We already have the first testnet products launch on top of RGB 0.12. For instance, BitLight Labs launched their web-based wallet. So there is a number of assets already been launched. And we expect that during the summer, there will be more assets, including mainnet assets and products being launched. I can't talk for specific vendors, but we know that there will be already products launched this June and July. By the end of months and early in July, you will have the first mainnet assets. And on our side, I can say that we also plan to bridge USD Tether to RGB on mainnet early this July. So you will be able to operate with the real world valued assets with RGB 0.12 in a matter of several weeks or even days. So the release plan we are following is this one. We already had the first release candidate for the consensus layer in May. We moved with the standard library to release candidate 2 in June. We already released the new version of RGB20 standard for fungible assets as well as standards for non-fungible assets this month. And we are working on RGB Lightning node integration of 0.12 version. So you can have a DEXs and other things as a part of important part of the ecosystem and the way how you can bring liquidity into RGB. And we plan to have it at the end of this month or early July. And we also, together with that, we will do a production recommended RGB full release about the 1st of July. After that, we will do an RGB node for professional use, like wallets, wallet providers, exchanges, and professional users wanting to run their own node. With a REST API, easy to integrate into the products, and we will be releasing this mid-July. So that's happens during these days, basically, and you are witnessing the RGB finally going live and alive. And together with these technological changes and launch of RGB, we will be also announcing some reorganization which will be happening around the RGB governance. As of today, RGB was developed and maintained by LNP-BP Standards Association, a non-profit body which was created specifically for the purpose of RGB development and making it independent from any company or corporate interests involved, and also the parties who has helped to finance RGB development wasn't able to influence the actual development effort, so no strings attached. Funding was happening. And this association was created in 2019 by me and Giacomo Zucco, and the time has come to reorganize this thing with our RGB release. And we are happy to announce that a new RGB consortium will be formed, which also will operate as a Swiss non-profit. And the RGB consortium will contain all the parties and companies who contributed to RGB development. More companies can be joined and apply, and the existing members of a consortium will decide on their membership. The main purpose of this RGB consortium will be not a further development of RGB, because we have planned that with the production release, RGB will be ossified in the client-side validation world. You can't do hard or soft forks the way you can do it in blockchain. It's even more complicated. And that's why the RGB consortium will be protecting the trademarks and be responsible for bug fixing and just overall management of the RGB and maintenance of the RGB code base. The RGB consortium will be launched this year, while LNP-BP Standards Association will become just LNP-BP Labs, a non-profit entity which will continue developing on top of Bitcoin protocol and Lightning Network protocol, but it won't be any more involved into the maintaining of the RGB code base. And those who are interested in RGB Consortium, you can find RGB Consortium in Twitter, follow it, and you will be able to subscribe for their own new updates coming from this official source. In terms of LNP-BP, other than RGB, and together with RGB, we reduce a number of libraries which we have developed through these years to help RGB development, and we are using them in RGB, but they have a big application scope outside of RGB itself. First of all, it's a BP library. It's a Bitcoin wallet library and implementation of all Bitcoin primitives, which is know-how related to RGB itself. It's fully abstracted from RGB and independent from RGB. As well as BP node. It's a Bitcoin indexing node, which have a lot of advantages comparing to Electrum and Explorer. Specifically, you can have a subscription for Bitcoin block reworks events, or you can subscribe for bulk updates with efficient API for new transactions to be mined and so on and so forth. And it's also faster and have a smaller indexer size. So this BP library will go live and release together with RGB, and we will announce that on Bitcoin mail list. It's basically a stack which presents an alternative for Rust Bitcoin and BDK libraries, providing a different implementation for those parties who are not satisfied with their compatibility, functionality, or stability. RGB over these years has become a full ecosystem, and many companies is building on top of it, releasing their products. I will briefly cover and go through these products, and among them there are decentralized exchanges based on Lightning, quite a lot of wallets, asset explorers, bridges, and so on. First of all, I would like to, of course, talk about the products by my company, because other than developing RGB, we are also running a Pandora Prime for-profit company, which is building on top of RGB and was providing a financial support for RGB development in the most hardest times when nobody else were ready to pay for that. The slogan for Pandora Prime is empowering individuals. So we see as an RGB and products we develop on top of it as a tool to bring more privacy and bring more of the values we all share to the community. And the products we are doing in Pandora Prime are primarily targeted in reducing thresholds of using RGB for developers. Specifically, we are targeting two directions. The first one is related to the integration of RGB, and the second one in bringing more liquidity to the RGB. We are launching the RaceSpace project, which is a privacy-preserving cloud infrastructure for RGB developers, with the help of Nodal and Michelle, who are also present here. As you know him, many know him as a Ketaminer. And this RaceSpace product will allow you to have a green light type of infrastructure. Many of you heard about green light, which is a Lightning project where you have a non-custodial solution for the Lightning Network. The RaceSpace will operate the same way for the RGB overall, both RGB on chain and RGB on Lightning. So it's a non-custodial solution, but it's also privacy preserving because you will be able to rent your own virtual server running the whole infrastructure stack, including Bitcoin Core, so you don't share your data with anybody else. And before, a developer waiting for RGB for all these years, they needed not just to wait for RGB release, but also to understand core RGB concept, write integration code, embed the quite huge libraries compiled from Rust into their mobile products, for instance, or WASM, fight with the performance and different issues related to async programming, and so on, paid for AWS to put something of that into the cloud and keep a DevOps running this cloud infrastructure. So it was like a huge threshold, like for any crypto, basically. And now the plan is that like they were literally dying because of that. Like, and now with the RaceSpace, it becomes much better because you rent Race. Race is basically instances in the RaceSpace, and you use HTTP REST API to talk to them from mobile wallet or a browser, and that's simple. And you don't need to understand anything about RGB at all. We are doing this also in partnership with a Thunderstack, and how it will work is basically we'll receive a key. It will be asymmetric public-private key-based authentication. Your device has the private key to access the API, and everything else happens in the cloud. There will be several instance types, starting from a very tiny one, which are not privacy preserving, but still non-custodial, and which will be very cheap, up to a dedicated where you run your own Bitcoin Core instance and indexer and everything else, and you fully protect your privacy. But it will be more expensive option for users who are able to pay and interested in supporting their privacy. Other than that, we are also bringing more liquidity, launching the color shift, and color shift is ERC22 RGB bridge, and this color shift will be issuing the LN USDT, the USDT bridge to the RGB, able to operate on top of the Lightning Network. And this LN USDT can be used with a Ray wallet, a wallet which we also have presented last year in Lugana Plan B. We have upgraded the Ray wallet to the 0.12 version. It's very easy to use mobile wallet where you can do instant payments from peer-to-peer just by putting two phones together or scanning a QR code. And this wallet comes from the day one with a Lightning USDT. There are other wallets. As I said, there are a few of them, and one of them is BitLight wallet, which is a web browser based Chrome extension wallet like MetaMask. There are other wallets being developed by other companies. In total, this summer vendors are launching about 5 different wallet solutions, for instance, Bitcoin Tribe from BitHive, BitMask from Diba, Iris from Bitfinex, and so on. There is also another wallet which we are doing for all these years and which finally gets support for RGB, being fully rewritten from the ground up, MyCitadel. And the difference of MyCitadel from Ray Wallet is that while Ray Wallet for a personal use, using mobile phone, paying for your coffee or paying for your lunch or sending funds to a friend, MyCitadel is a professional wallet which is purely focused on multi-sig environments created for companies, power users holding funds for a long period of times, or asset issuers, because it helps you to manage the secondary issue of RGB assets. It helps you to manage the corporate accounting with the different assets, including Bitcoin and USDT, having a multi-sig between your directors, such that when one director creates a transaction, others instantly see it in their wallet and are able to add signatures to it. Working with like you will see the, like for instance here in the bottom of the screen, the wallet organizer, where you can have a multiple companies, and each of these companies may have a multiple wallets, and each of these wallets may have a multiple signers and their own independent history of operations. That's it. That's the overview how we plan to bring RGB to life this summer. And we hope that you will all be parties who will be able to use this technology in a very short period of time, and also those who were looking for RGB release for all these years to issue their assets or starting integrating. You are welcome to join the club. Thank you very much. Any questions?
What is
your... We're drawing several icons, and also for all these wallets, like making them compatible with the new liquid glass design from Apple. I'm not sure they will have an ICO file extension, but like pretty much that can... Well, in July we are launching the Rayspace and Thunderstack, and it will be providing REST API for wallets. So it will be the easiest way to integrate RGB. You will just have, if you have a non-custodial wallet, you don't need to put RGB data right into your wallet application. You can use these cloud instances or host your own infrastructure in the cloud with the source code we will be publishing together with the launch of the product. The existing wallets, they are not using this infrastructure yet. They spent several years integrating RGB and following all the changes and updates right into their wallet software. It's a harder path. Anybody still can use it already today. And for that, they need to go into RGB WG organization through the -RGB-WG in GitHub, and there will be an RGB repository with RGB runtime, and that's the place where they can start integrating already today. But if they can wait for a few weeks, they will have a much easier option with a cloud-based API.
What about mini-script support? Is it planned?
Well, we support all the technologies on Bitcoin itself, but for any support you need some libraries implementing it and making it simple to use. Actually, we started MyCitadel as the first wallet which were supporting my mini-script, and we moved out from it because we were not satisfied with what mini-script gives. Mini-script is great for science and research applications, but it has a lot of restrictions reducing its practical use in the wallets. For instance, you can't combine it with any non-standard wallet descriptor like used in Lightning today. And that's why we moved to a new thing we developed specifically for addressing this issue called script templates. With the script templates, you can express any, including non-standard Bitcoin as a descriptor without the restrictions of mini-script. And the MyCitadel comes with these script templates.
Why USDT from Ethereum and not directly issued by Tether on RGB?
Because we are not Tether, we can't directly issue as Tether on RGB. So for sure, Bitfinex will do it. Tether will do it, and they have announced multiple times that it's in their plans and strategy. But it will take time because they are larger and they need to to do through a lot of, including legal procedures, and that's why we would like to give users ability to use LN USDT today. And when USDT comes, either they will use already existing LN USDT or they will do their own asset with a migration, so a user can go out of LN USDT and come to USDT issued by Tether.
Thanks.
Thank you very much.
Thanks.
Yes, have a good day.